Chemistry, the Central Science by Theodore Brown. Chapter 5, Thermochemistry. Modern society depends on energy for its existence. Energy is used to drive our machinery and appliances, to power our transportation vehicles, to keep us warm in the winter and cool in the summer. It's not just modern society, however, that depends on energy. Energy is necessary for all life. Plants, such as those in the chapter opening photograph, use solar energy to carry out photosynthesis, allowing the plants to grow. The plants, in turn, provide food from which we humans derive the energy we need to move, to maintain body temperature, and carry out bodily functions. What exactly is energy, though, and what principles are involved in its many transactions and transformations, such as those from the sun to plants to animals? In this chapter, we'll begin to explore energy and its changes. We're motivated partly by the fact that energy changes invariably accompany chemical reactions. Indeed, sometimes we use a chemical reaction specifically to obtain energy, as when we burn fuels. Thus, energy is very much like a chemical topic. Nearly all the energy on which we depend is derived from chemical reactions, whether those reactions are associated with the combustion of fuels, the discharge of a battery, or the metabolism of our food. If we are to properly understand chemistry, we must also understand the energy changes that accompany chemical reactions. The study of energy and its transformations is known as thermodynamics. In this chapter, we'll examine an aspect of thermodynamics that involves the relationships between chemical reactions and energy changes involving heat. This portion of thermodynamics is called thermochemistry. We'll discuss additional aspects of thermodynamics in Chapter 19. What's ahead? Section 5.1, the nature of energy. We begin by considering the nature of energy and the forms it takes, notably kinetic energy and potential energy. We'll also discuss the units used in the measuring energy and the fact that energy can be used to accomplish work or to transfer heat. To study energy changes, we focus on a particular part of the universe which we call the system. Everything else is called the surroundings. Section 5.2, the First Law of Thermodynamics. We'll then explore the First Law of Thermodynamics. Energy cannot be created or destroyed, but it can be transformed from one form to another or transferred between systems and surroundings. The energy possessed by a system is called its internal energy. Internal energy, E, is a state function, a quantity whose value depends only on the state or condition of a system now, not on how the system came to be in that state. Section 5.3, Enthalpy. Next, we'll encounter a state function called enthalpy, capital H, that relates to energy. This function is useful because the change in enthalpy, delta H, measures the quantity of heat energy gained or lost by a system in a process occurring under a constant pressure. Section 5.4, Enthalpies of reaction. We will see that the enthalpy change associated with a chemical reaction, delta H reaction, is given by the enthalpies of the products minus the enthalpies of the reactants. This quantity is directly proportional to the amount of the reactant consumed in the process. Section 5.5, Calorimetry. We will next examine calorimetry, which is an experimental technique that we use to measure heat changes in chemical processes. Section 5.6, Hess's law. We will observe that the enthalpy change for a reaction can be calculated by appropriate enthalpy changes for other reactions. To do so, we apply Hess's law, which uses the fact that enthalpy, like energy, is a state function. Section 5.7, Enthalpies of formation. Then we'll discuss how to establish standard values for enthalpy changes in chemical reactions and how to use to calculate enthalpy changes for reactions, delta heat of reactions. Section 5.8, Foods and Fuels. Finally, we can examine foods and fuels as sources of energy and discuss some related health and social issues.